relationships, and interpolation and extrapolation. In order to interpolate and extrapolate, we need to use a line of best fit. So we need to understand what exactly a line of best fit is and how to create one. If we look at the graphs below, only one of these is a good line of best fit for the data that you see. If we look at this line of best fit, it goes upward and rises pretty steeply, a little more steeply than the data. So this one's too steep, and the points aren't even. And what we mean by the points aren't even is we've got 4 points under the line and only 1 above. And we're not following the end behaviors. If we look at this one, again, it's a little better slope. But, again, the points are not evenly spaced. And this one here, 3 below, 2 above, 2.5 above is not too bad. This one here is 3 below, 3 above, through lots of points. So I would say this graph here is my best choice. Okay, not quite steep enough, not quite following the ends either. If I look, I'm totally ignoring the data at this lower end of my graph. So the line of best fit, as I said already, is used to make predictions for values that are not actually recorded or plotted. Interpolation is when I go in between. So if you see the dotted line that's taken up to the line of best fit and across, we can read off values or predict values that go in between some data. When we do extrapolation, we're going beyond the line. So you can see how this line of best fit was extended past all the data points. The other thing it can have happen to it is I can extend it below the data points. Okay, so I'm going outside the points, and it's the same process occurs. I draw a line up to the line of best fit and across. I could also have drawn a line across to the line of best fit from the vertical axes and down to the horizontal axes to get data values of the independent variable. If I look at this example, it's talking about a science project where Kayvon recorded the minimum temperature in her backyard for the first 10 days in March, and the data is shown below. The independent variable is day because time's passing regardless of what else I do. The dependent variable is the minimum temperature because, of course, temperature is regulated by the time of year and what's happening in each season. So if I want to create a scatter plot of the data with an appropriate title and scale, the first thing I have to do is count the boxes up. So if I do that, I'm going to start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19 vertical boxes. And if I go across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've got 19 boxes on both scales. Now the next thing I need to do, remember for the horizontal scale, I'm going to take my highest value, which is 10, subtract my lowest value, which is 1, and divide it by the number of days. So 10 take away 1 over 19, divide it by the number of boxes. 10 take away 1 is 19, 9 over 19, which is about 4.73. Not a very nice scale, but I could round that to 0.5 if I wanted to. I always want to round up. So if I draw my axes on here, this is not going to go very well because, of course, I'm not using a ruler. So I'm not doing a very good job here. I apologize. You guys are all going to use rulers. And I'm drawing a horizontal axis. And if I count my scale, I'm starting here at 0. And if I count by 0.5, this first tick is a second tick is a 1. The fourth one is 2. The sixth is 3. And every other tick I'm going to label with a number. Or every other box. Probably 8. Oh, I ran out of room. How did that happen? Because I started my horizontal scale at 1, but I started at 0 here. So if I wanted to not have to telescope my axes to start, I needed to account for that 0 in there. So that would have been 10 divided by 19, and I actually need to go a little bit bigger in order to make this work. So I might just make my life easy and count by ones. Look at that, I'm getting better at drawing a straight line. I think I spoke too soon. Now I don't want to label every tick because it's going to make it cluttered. 1, 2, 3, 4, 5. I often mark every fifth box. 6, 7, 8, 9, 10. And we said that was day, and it's day of March. So we really should make sure we say that it's the day of March. And vertically, same process. We need to go back to our table of values. And we're going -9 to 3. So the largest number is 3. Subtract -9 divided by 19. Ends up being about 0.63. Again, I don't want to graph that. And I'm also going to have to recognize that I started my vertical scale at 0, and I jumped ahead of myself there and should not have, because my lowest value is in fact -9. So I'm going to have to bring my scale up a little bit. So I'm going to make, and I'm counting by ones, I said, -10, -9, -8. And again, you can see how cluttered it's getting. So we don't want to do that. And we'll start -10, -9, -8, -7, -6, then -5 right here, -4, -3, -2, -1, and 0 right here. And I need to redraw my horizontal axes. And again, I'm still not drawing my lines very straight. I apologize for that. I need to label my vertical scale as temperature, and it's in degrees Celsius. And I need to renumber my scale here. Of course, this line should be going right here. It'll be much prettier on the next page. I'll show, when we get to drawing a line of best fit, I will use a better graph. 6, 7, 8, 9, 10. And I'm going to erase the other scale I had going down here because I didn't think before I started. It's always important to make sure you think it through before you begin what you're doing. Now I need to plot my ordered pairs. On day 1, the temperature is -9. So the day is 1. That's the ordered pair 1, 9. That tells me go right 1. And sorry, it's 1 and -9 and down -9. The next point is 2, -6. So I'm going right 2 and down 6. Next point, 3 and -3, right 3, down 3. Oops, sorry, went too many screens back. 4 and -5, so right 1, 2, 3, 4, and -5. Day 5 was -4, so right 5 and down 1, 2, 3, 4. Day 6, I keep going the wrong direction, is -1. Day 7 is 0. So right on the axes. Day 8, I think, was +1, but I can't remember. -1. Good thing I looked back. So okay, 8 to the right and down 1. And day 9 is 2 degrees. So right 9 and up 2. And I believe day 10 was 3 degrees. And I did remember that correctly. So I'm going right 10 and up 3. And if we were doing this neatly using rulers and graph paper and not the Smart Notebook software, our graph would look a little prettier and look something like this. Now, what are the trends in the temperature on the graph? I can look and see. As I move towards the right, the number of days in March increases, the temperature is getting bigger. So what type of correlation is that? That's a strong positive correlation. And because there's a pattern to the data, I can add a line of best fit to my graph. So if I try and pick up my line of best fit here, which is not going to work for me because I lost the screen I was using. Okay, can I grab a hold of it? No. Okay, so back to our graph, we're going to grab our line of best fit, and we're going to drag it over here, and we're going to drag it around, and we're going to try and make sure that we get as many points above and below as we can, and that we try and follow the trend that exists at both ends of the data. And that line of best fit looks pretty good. I've got 1, 2, 3, 4, almost 5 points above and 3 points and a bit below. So it looks pretty good. And before you come to class tomorrow, I'd like you to do page 14, number 1, A, B, C, and D, and number 2, A, B, C, and D.